Okay, so today, Monday, we're going to do some review. And what I thought I would do is I would start with chapter 11 because that's the newest chapter. And so that's the chapter that we haven't been tested on. And so this is coming from the chapter test at the very end of the chapter, and you can get it from the ebook. And I put instructions on the top of XYZ homework. But this one here, basically, they want you to simplify. So there's just 4 terms, 1, 2, 3, 4 terms, and 2 of them are alike, and the other 2 are alike. So so these two, 9x, and then subtract 3x, you would then simplify it as 6x. So those are done. Now these two are 7 subtract 12. And so you may remember what you do is you subtract the 2 numbers, which is 5. And then because it's adding and subtracting like this, you take the sign of the larger one. So you end up with negative. So this ends up being -5. And there's nothing more to do for this problem. This is basically all they wanted you to do. So that was just practice combining like terms. So those were alike, these were plain numbers, they were alike. So this one is similar. The B terms are here and here. And so what you're thinking is you're putting those together, whether you write it or not doesn't really matter. And then these two are alike, and be sure and pick up the sign. So that's -1 and then -3 here. So these two go together and these two to go together. So this is 4B take away B. And you could have to assume that's really 1B when they say B. And so 4 take away 1 would be 3B. Okay, so I inserted the 1 as a reminder, that it's really when I subtract B, I'm subtracting 1B. And so that leaves me with 3B. These two numbers together, this is like going down and then going down further. So it's a -1 and a -3. And so you keep going lower and lower. So it's -4. Okay. Now the rules for multiplication and the rules for division are different, but we have to keep these things in mind. This type of problem, they usually use the word evaluate, which really is to find the value. See the word value in there? And so they're telling you the missing number X is 3. And so these are 2 separate problems, by the way. So this one here, what you do is the minute you see X, this number drops in. And I've been encouraging you to put parentheses around it. Now, especially when there's negatives involved. But what this does is remind you that these 2 numbers are multiplied. From the very, very beginning, those 2 numbers were multiplied. 3x meant 3 times x. And so I don't want you to lose track of the fact that these are multiplied. So this makes 9, and then you subtract 12. And again, that's like the previous problem. The difference between 12 and 9 is 3. But the 3, remember the 12 was negative, that 9 was only 9 was positive, so it ends up negative. Same as before. Now, this is a slightly different problem, but it's the same type where you substitute that. Again, if you would put down this, and the minute you see your X, put parentheses and put in the correct number. So this is 3. And then this is telling you to do the opposite of that. And so the opposite of 3 would be -3. Okay. So this is almost like multiplication because you could think of it as -1 times +3. So the 1 negative can be interpreted as the opposite of 3, or like a negative times a positive is a negative. And so -3 plus 12. Now this is different because the two are opposite signs. And so you take 12, take away 3 is 9. But the bigger number is the 12, the positive one. And so it ends up being +9. How's that? Okay. So what they eventually did after they practiced problems, they eventually asked you to solve. Now, these are two separate problems. So this one here, when they say solve, they're trying to say, what is X? Or whatever letter they've got here. And so this is X, but X has 7 subtracted from it. So the whole idea is to get X alone. And so to get rid of -7, you would add. And this is basically what's happening each time. So the negative and +7 go to 0, and you're left with X, just what you wanted. So this is that same story. You have a -3 and a +7. The difference is 4. And because the 7 is the bigger one in this case, it's positive. Now, occasionally they pull back, they bring back fractions. And so this one here, A, has a -3/4. And so to get rid of that, you do the opposite of subtracting, which is adding. Okay, so the -3/4 and the +3/4 hit the dust, and you're left with letter A, which is what you want. The trouble is, what you have to do is combine those two. So that's review. So I'm going to write these down vertically and figure out what to do. This is -5/8. This is +3/4. And when I see the minus, that's typically the book or the program wants it here, I put it here so that it's handy and I don't miss it. And so I have to put these two together. The common denominator in this case with the 8 and a 4, if the bigger number is good, go with it. So I'm going to use 8. And so this one is just plain copy it. So I'm going to just plain copy it. The trouble with this one is 4 needs to be 8. And so you need to multiply it by 2/2. 4 times 2 is 8. 3 times 2 is 6. Okay. So I've got a common denominator, 8. And I have to combine these two, -5 with +6. This is really 6, take away 5, which is 1. So that is the final answer. So I kind of did it on the side there. And so this added to this, done properly, is 1/8. And so that's what you would report. Okay. Now I want to remind you of this. This one, typically when a number is multiplied to y, what you want to do is divide. But with a fraction multiplied to that, the simplest road is to multiply by the reciprocal. And this avoids ugly numbers. So I multiplied this side by 3/2, and I multiplied this side by 3/2. Why is that working? Because the 2's cancel, the 3's cancel, and I'm left with y, which is just what I want. And over here, notice how I write my 18 high, so that's 18/1. We need to simplify this right this minute. And so the 2 and the 18 would simplify. That would be 1, and 2 into 18 is 9. And so one way or the other, you've got this. 9 times 3 is 27/1, which we would just say 20. Is that okay with you? So this was slightly different. Typically, when you have a multiplication problem, and there it is, the x multiplied to a whole number, all you have to do is flat out divide. So then in this case, x would be 3 into that is 8. So typically that's what you do when it's multiplied, but this was different. That's why I picked it to show you. It's 2/3 a fraction times y. And so this was the better way to do it. I think we went over that. Now, this, here's the equal sign. I've got 3x on the one side and I've got 5x on the other side. I cannot keep the letters on both sides and expect to have an answer. So what I encourage you to do is to look at the two x's and find a smaller one and move it. And it would be this one. This is smaller than that. And so this is considered a positive because there's no subtract sign or negative on it. And so this is positive. I would actually subtract 3x. And over here, I would do the same thing. And this is partly why I write things right below it, so that I can match up x's to x's and so on. So 3x minus 3x is 0. And so I'm just throwing it away. What I'm left with is -7. Over here, I've got 5x, take away 3x. That would give me, they're like terms, so I can combine them, 2x plus 1. This scenario, it's not done. It's only done when we've got x equals. But this is what I call the two-step problem. I've got to get rid of the 2 and I've got to get rid of the 1. The order that you do this is critical. And so if you would get rid of the single number, the number that's added or subtracted from the x, that's your best plan. So subtract 1 from this, and then I'm going to subtract 1 from this. And these are like terms. So -7 and another -1, that would total -8. And over here, I'm left with 2x. So this is your normal scenario. When you have a number times a letter, all you have to do is divide. Divide by 2, divide by 2. So 2 over 2 is 1x, which we typically just say x. And this is division, the same rules as multiplication. So and 1 negative and 1 positive, 1 negative makes it negative. And 8 divided by 2 is 4. So the rules for adding and subtracting are completely different than the rules for multiplying and dividing. And so the very first thing you want to do is make sure you're in the right ballpark as far as how you go ahead and do these. Questions?
I have a question.
Okay.
That was a problem. It looked really deceptively easy, but I had a lot of problems with it. It's x over 2 plus x equals 3.
So this was x over 2 equals 3?
No, x over 2 plus x equals 3.
Oh, we actually didn't do very many of those.
I couldn't, yeah.
Yeah, this is actually 1/2 x. So x over divided by 2 is like 1/2 of an x.
Uh-huh.
And this is a full x. I think if you rewrote it, yeah, these were like terms, but with a fraction, people, are upset. When you take a number and divide by 2, it's like multiplying by 1/2. So you have half of it, and then you have a whole of it, And so what is 1 plus 1/2?
1.5.
1.5. But it turns out 1.5, it's easier if you write it as, remember, making it an improper fraction, that would be 3/2.
Mhm.
As we go into algebra, this becomes easier to compute than that. And so this would be 1 1/2 would be 1 1/2, better known as 3/2, multiplied by x equals 3. I've now got out of the mess, and this. Do you remember what you do with 3/2? I'm going to bring out my orange.
I'm still lost with, okay, I see the half. Okay, you did 1/2 plus the one, you got 3/2.
Yeah, so 1 1/2, you told me it's 1 1/2, right? A 1 1/2 is 1 1/2. But it probably is easier to use 3/2 instead of 1 1/2. You could use 1 1/2, but then it's not as pretty. If you have 1 1/2 times x equals 3.
Okay, so then it's 3/2 times.
It's easier to do it that way. And this is why this becomes preferable. So what you do, then this is the scenario where you have a fraction times x, you multiply by 2/3 on both sides. So the 3's cancel out, the 2's cancel out, you're left with x.
Mm,
This is 3, which is 3/1. In this case, the 3's cancel out, so you're left with 2. 1 times 2 is 2. I can see why that one didn't work.
okay, thank you. Yeah, it was in my home and I couldn't find one like it, so, okay, thank you.
Yeah, we kind of kept it a little bit at a better level.
Yeah,
Yeah, I tried.
Can I explain a problem as well?
Certainly.
Okay, thank you. It's it looks like mixed numbers. So it was 177 and 1/8 plus x is equal to 183 and 1/4.
Okay. So first of all, you want to make sure you know what type of problem you're doing. And you usually can tell by the instructions. The instructions would have to say solve, because this is an equation. So it's like a left side, a right side, and equal in the middle.
Okay.
So the instructions would have said solve.
Okay.
So the rules that you do, even though the numbers are messy, the rules have not changed.
Mhm.
You want to keep the x, and you want to get rid of anything that's keeping the x from being by itself. And so this number has to go. And so because this is assumed positive, because there's no negative on it, to get rid of this number here, you're forced to subtract.
Okay.
And over here, the minute you do that,
Got it.
so that even though it got ugly, the process did not change.
Mhm.
You want to ditch the number. And so see how it's added to that? You want to subtract it. You want to subtract it. Now, this problem here requires some work, but I think we can handle it. And this is review. Subtract, I'm going to write it bigger so it's easier to follow. So it's going to need a common denominator, but
Mhm.
fortunately the 8 will do. So I'm going to come over here and go 183, and I need it in 8s. And over here I have 177, and I already have it in 8, so I'm going to just grab it. But this one right here, and this is review for fractions, which doesn't hurt us one bit. 4 times 2 is 8. 1 times 2 is 2. So this problem needs to be subtracted. So the fractions 2/8 minus 1/8 would be 1/8. And 183 take away 177, that's 6. So that's your answer.
Perfect. Thank you so much.
Thank you. Okay. So I wanted to do a few more, and then we'll, go to another chapter. But this one here, I wanted to remind you about distributing. And so this is where, go orange. This is where you multiply the 2 to this and then the 2 to that. So this would be 2 times x would be 2x. And this is be 2 times the -5 would be -10. And that's equal to -8. This is a lovely two-step problem. I've got the 2 and the -10 to get rid of. Remember, I want to get rid of the single number first. And so I want to add 10 and add 10. So the plus minus 10 is 0, and what's left is 2x, okay? These two have to be combined. This is 10 and subtract 8. So that's just 2. This is the one-step problem, and this is assumed multiply. So what we do is we can easily divide. So that's 1x, which is x, 2 over 2 is 1. Okay? So the very first thing we had to do was get rid of those parentheses so we could actually get at the x. The x was kind of lost in here inside. And so we have to distribute to get it out. And then we get rid of the single number first. Let me see how many more I've got. I guess I'll do this one. How's this? Yeah, that's all right. Let's do it. This is the one level up, but it's basically 2 distributes. 3 times 2 is 6x. And 3 times 3 is 9. Okay, that's better. This one needs to multiply by -3. So this is, I think I picked this one because of the problem right there. So -3 times x is -3x. That's not a problem. But this one here, the next one, it's a -3, pick up the sign, times a -5. And you may remember when you multiply 2 negatives, minus minus, it goes plus. And that's where the arrow would be, a -3, pick up the sign, -5 is plus 15. Okay? If you get that far, you're halfway there. Now, I've got x's on both sides. I need to decide which one's smaller, so I avoid negatives as much as possible. This one is clearly lower on the number line, and it's -3, -3x. I'm going to add 3x to get rid of it. This is the opposite. I would have to then do the same thing over here. So what I have, take that away, 6x plus 3x would be 9x. I'm going to copy the plus 9. And what I've done now is the x, they're all over on the left. And what's left over here is the number 15. I've got a 9 multiplied to x. I've got a plus 9. This is the one that's got to go. So I'm going to subtract 9 and subtract 9. So this leaves me with 9x. I'm glad I did this one. This is interesting. 15 take away 9 is 6. Now, people, most of the time when we've done these, the answer came out a whole number, but it doesn't always happen. And so you just do the same steps. And that's why you have steps so that you don't have to guess anymore. You just do the steps. So we divide by 9 and we divide by 9. So what I have here is x is 6 over 9. okay? The trouble with 6/9 is they'll mark it wrong because it's not reduced. So if you divide each of them by 3, divide this by 3, you get 2, divide this by 3, you get 3. That's the answer that you want. So when you have fractions and they say simplify, this will not cut it. This is what they want. Okay? So it needs to be reduced fully down to 2/3. Okay. I think I just have one more. Oh, okay. This is just a decimal, but the rules have not changed one little bit. I want the A alone, so all I have to do is subtract. 3.7 subtract 3.7. Okay? So this would be 6.1. How's that? What I wanted to do, and again, if you see problems that have given you trouble, there's a few, especially in this chapter where the topics got sort of difficult. I want to sort of emphasize the ones that we have covered and that might be on a final. This first topic is perimeter. And you can use a formula, or you can just march around and get the outside edge. So if this is 9, the opposite side would be 9, and I had it in inches. And if this one's 12, this would have to be 12. So the perimeter, you'd have to have 2 of the 12s and 2 of the 9s. And so 2 12s and 2 9s. That's the formula. Or you could just add. So this is 24. This is 18. What is that, 42? I think it's 42. What do you think? I think it's 42. So that's 42 inches. And so that's perimeter. So you're going around the edge. And so that's it. So this one here is a triangle, but they want it, if you still want perimeter, all you have to do is add those 3 numbers. So 1.8, 3.2, and the 4, which is actually 4.0 if you want to line them up properly. So 8 and 2 is 10, carry a 1. This is 4, 8, 9. So I'm getting 9.0. So I think they would just expect you to put in 9. Then they'd probably have the word feet here. Okay.
Okay.
So, yes.
I have a question.
Okay. Along this line.
Yeah, I did a problem of perimeter.
Okay. So can
Mm.
you tell me, or do you need to share?
Let me tell you,
You're going to tell me? Okay, go ahead.
it was a triangle.
Yes.
One side was X,
Okay.
another side was X. That side, it is X plus 3.
Okay. Did I get it right? Even though I don't have the picture just right?
Yeah, that is
X
it.
and X plus 3.
Yeah, they gave
Then
us
they told you the perimeter.
equals 15. No, sorry, 51. Sorry, I'm sorry. 51.
Okay.
Yeah.
So it's this number. This is a number, even though you think it's a letter. It's a number. This is a number. This is a number. So to do perimeter, just like the one we did with when we had the numbers, you would have X, and then another X, and then an X plus 3, and all of that together is supposed to equal 51. So really, all we did was march around and write down what they have, that, and that. Now, the question is, these 3 terms, how many X's do we have?
3.
we have 3x. And then it's a plus 3, we can't throw that away, equals 51. So we've created the equation from the picture. Now we have a two-step problem. The 3 to the x and the plus 3. This one has to go first. So I'm going to subtract 3 and subtract 3. The plus minus 3 goes to 0, and we're left with 3x. And 51 take away 3 is 48. We now have what I call a one-step problem. There's just one thing to do. It's 3 times x, divide. And it turns out that that makes 3 into 48 is 16. You can do it out. Okay.
Okay.
And you could see it if you had a minute to check it. If this was 16 and this was 16 and this is 3 more than that, that would be 19. If you added those numbers, 16, 16, and 19, guess what you're going to get? You're going to get 51. Okay. So
Okay.
this is I'm pretty sure they wanted to just know what x was, wasn't it?
Mhm.
I'm pretty sure that's what they wanted. And so x was 16, and that's what made this equation work.
Okay, thank
Is that
you.
okay? Yeah.
I stopped on 48. I did not divide.
You didn't divide?
Yeah.
Ah, all
Mm.
right.
Mm.
So let's see what else was in that chapter 8. There were some problems on area. And so if it's a rectangle, if this is 6 meters and this is 4 meters, if they want the area, we're talking inside, not the edge. And so area is length times width. Now you could have a half a page of formulas or whatever you need for the final. And so if you need these formulas, then write them down. You could even show a little picture if that helps. But this would be 6 meters multiplied by 4 meters. And 6 times 4 is 24. They're going to have this square meters on the side, but what you would need is to put in the 24. Let's do a triangle. If this much is 10 feet, and this much is 3.5 feet, this is the height. This is considered the base. Whether you care about that or not doesn't matter. The area is 1/2 times the base times the height. So the base is the bottom, and notice how the height is perpendicular, 90 degrees. And so these are the two numbers that have to be multiplied. So I would go 1/2 times 10 times 3.5. I just put in 3.5 just to be annoying. So 1/2 of 10, so you've got to multiply these three numbers. So 1/2 of 10 is 5. And then you'd have to multiply 5 times 3.5 to get your answer. So let me just do that. 3.5 times 5. 5 times 5 is 25, carry a 2. This much is 15, and 2 is 17. With this multiplication, there's one decimal shift, and so your answer would be 17.5. And it would actually be square feet, but I think you'd only have to put in the number. Okay? So if there's a decimal involved, we use our decimals and so on. But basically that is your formula. Now, let me think what else. The ones that people have the most trouble are the circles. So there's one formula for circumference. And there's two formulas for it, and I've been basically encouraging this one, but there's another one, 2 pi r. But the diameter, let's say this was 5 inches. The total distance across would be 10. So the radius would be 5 inches. From the center out, the diameter would be 10. So it might be good at the very beginning to establish that fact. And then if you have your list of formulas, sometimes people have them memorized, sometimes not, but you can have a page with your formulas. Circumference equals 3.14 multiplied by the diameter. And in our case, this diameter is 10. And I picked that number so that I wouldn't even need anything. So when you multiply by 10, the decimal point shifts 1 to the right. So it would be 31.4 inches. Or you can multiply it out, but I think just moving the decimal is a safer thing.
So the radius 5, we not use that one?
Yeah, some people learned the other way, which is circumference equals 2 times pi times the radius. That will give you the exact same answer. 2 times 3.14 times the radius 5.
Okay.
Because the 2 times 5, if you multiply those first, would be 10. And then 10 times 3.14 would give you the exact same answer.
Okay.
So it's just whichever one you memorized. And but you have to be able, sometimes they'll give you the diameter and sometimes they'll give you the radius. And so you have to be able to go back and forth between the two. And usually it's easiest to see on the picture. Okay.
Mhm.
I'm gonna quickly do this one, although pi r squared, you can sing it. I'm gonna keep the same one, 5 inches. So somebody recently told me what they had trouble with this, and because they didn't square it. So the pi is 3.14. But what happens is the radius, whatever the radius is, has to be squared. An order of operation makes you do squaring before you do multiplication. So 5 squared is 25. And that would have to be multiplied by 3.14. So this is not our favorite, but that can be done. 5 times 4 is 20, carry a 2. 5 times 1 is 5 and 2 is 7. And this is 15. And then 2 times this is 8. 2 times 1 is 2. 2 times 6, 2 times 3 is 6. 0. 15, carry 1. 8. So I did this quickly, but 1, 2, 1, 2. The answer is 78.5. Okay, so this formula for area is pi r squared. And so if you don't know that formula, that's what you need to write down. So you have it handy. Okay. Anybody remember any other questions from that section? Because we didn't, I know they got really carried away, but we tried to keep it to a reasonable level.
There was a question on the homework in that section
I'm
where
sure.
it was
Go ahead.
it was a composite figure. They wanted us to figure out, it was a triangle, a rectangle, and a half circle at the end of the figure.
Can I tell you something? Ignore
Yes.
it for now. Just
Oh,
is that okay with you?
that's beautiful. Thank you.
Okie dokie.
All right.
All right, somebody. Okay, so the other thing is for each of you, when you finish this course, you go into Math 87, which is beginning of algebra. And so it's kind of critical that you can do the rules for add, subtract, multiply, and divide. That we did in chapter 10. I don't know if you remember. So I'm going to see if I can find us some problems. Yeah. Okay. Oh, there we are. Okay. Let's see what I got. All right. This might be part of a bigger problem, but when you see subtracting a negative, this is how it ends up being plus. So this ends up being +7. So let me see if let me find one. -65 minus -29. Okay. So this is where it appears in a problem. So the first thing I'm drawn to is this little piece here, minus, subtract a negative, the opposite of a negative. I don't know how you shake it, it's plus. So if this is too messy for you, rewrite it neat, which would be -65 plus 29. You can then ignore the mess and just focus in on the simplified version of this. You have one negative and you have one positive, and you're trying to put them together. The negative is more than that. You end up subtracting the two numbers, and I would put the bigger number on top, just make it easier. This is 6, it's a borrow. So I'm getting 36. If you see an error, let me know straight away. But I think it's 36, but it's negative. Is that right?
Yes.
Yes, okay, good job. So let's look at some others. And -35 divided by -7. So the rules for division are totally different than the rules for what we just did, which was like adding and subtracting. The two negatives, but it's actually like that minus if you think about it. The two negatives make it positive. So all you have to do is 35 divided by 7 is 5, and two negatives make it positive. So this is where you've got to be letter perfect as far as your work is concerned. Let me try one like this. So there's a little bitty fraction, but we're not afraid. I wrote the -18 high because I want to put it over 1. There's division here, there's multiplication. But the good news is the rules are the same for both. And so I see a negative here and a negative here, so I know it's going to be positive. I can then ignore the negative signs and just simplify this. And the 2 and the 18 could actually reduce. 2 goes into 2 once and into 18 9 times. I think we did this exact problem earlier without the negatives. So 3 times 9 is 27. And then double check the sign. because the sign is going to get you wrong just as much as the number. And so negative times a negative is a positive. That one is good. Okay. Let me try this one. Let me see if I can put problems together. Negative. Okay. So I've got addition, I've got subtraction, and the fraction line is division. So what you want to do is simplify the top, the bottom, and then see where you stand. So this is addition. This is a -5, and then we added to it a -3 more. So this is going down and then further down. So you end up adding the two, 8, but it's -8. In other words, you kept going lower and lower. You borrowed $5, now you borrowed $3, now you owe $8 or something like that. This one here, 5 take away 7, is another way you see these problems, but you're subtracting more than you had. So the difference is 2, but it's also negative because you took away more than you had. This is where you landed. So the one negative and the other negative, 2 negatives make it positive, and then 8 over 2 is 4. How's that? Now, I have no idea if this is going to come up, but occasionally they use these words, and I noticed I was tutoring somebody recently, and they had forgotten the words. And so they could actually present a problem and just tell you, find the product of -8 and 3. And so unless you recognize this word as the instruction of what needs to happen with the numbers, it's not going to work because you don't know. Do you add, subtract, multiply, or divide? Anybody know?
Multiply.
This is multiply. So this is add, this is subtract, this is multiply, and this is divide. So really the problem is this. So I have 1 negative times 1 positive, answer 1 negative. Okay,
So, do they want like the equation or do they want like the complete flat out answer?
when they say the product, they're only saying give the answer to this problem. So they wanted this. Mhm.
Gotcha.
Yeah, there's occasionally been a time where they wanted you to translate, and then
Mhm.
all they, I do remember there was a few like that recently, where all you wanted to do was write the equation,
Yeah.
but that's, in fact, I think I had one and I didn't show it. Let me see if I can find it. Oh, here it is. Good job thinking about that.
Yeah.
I
Thank
skipped
you.
over that one by mistake. So this, this one is twice the sum. Now remember, sum is adding. So the sum of a number in 3, I'm just going to use X. That's the sum, X plus 3. And you can't really add them because they're unlike terms. So that's the sum, but now we want twice that. So the way they had us do it is put 2 and then the parentheses, so you double both of these. It's twice the X and it's twice the 3. The word is equals. And -10 is -10. Thank you for reminding me about this one. So the sum was X plus 3 twice put a 2 out front. And that was one example where they actually used parentheses. So they wanted you to actually solve this. So if they had said, write the equation, you'd have been done right here. But on the problem, the one I copied, it said solve it. That's a different story. So this would work for the equation if that's all they asked for. So look for that. But this one said solve it. And so you know what you have to do. You have to double the x, so that's 2x. And you have to double the 3, so that 2 times 3 is 6. And over here is just your negative 10. This is that 2-step problem. I want you to go after this first. I want you to go -6 and -6. Okay, that went away, but this is left with 2x. But over here, this is like borrow, borrow. So borrow 10, borrow 6, you're now -16. This is that one step, you just do whatever's needed. And this is 2 times x, so you would just divide. So in this case, the answer you would turn in, if they said solve, you would say -18 or -18. If they said write the equation,
Is it 8, right? No, -8. It's not 18.
I'm sorry. Thank you. Yeah, 8. I don't know, I got carried away. Thank you. 8, -8. Okay, thank you. I was so busy coming up here, I lost it over here. But if they said write the equation, then that's what you would have typed in. Is that okay? I think that's what we were asking.
Yes.
Yes.
And does twice the sum have to be like, is that meant for the parentheses?
Yeah, the parentheses forces you to double both of them.
Okay.
Because this is
Gotcha.
the sum, and that's, it basically doubles the whole thing. Because if you didn't have parentheses, you'd only double the first number.
Okay.
Yeah.
Gotcha. I understand.
Okay, good job. Thank you for the correction, because honest to goodness. Okay,
Thank you.
yeah, so let me see how we are. So it's 11:26, which we still have about 10 minutes. So so I guess what I want to do right this second is talk about Wednesday. Now, some people could actually have a final on Wednesday, right? Because Wednesday is part of the finals. Anybody have a final?
I don't.
Yeah, I have a final for my
Yeah,
other
I mean, you could easily have a final during class time, so we don't need to have a class. It's kind of up to you. Let me go over to, if I can get
Uh,
there.
Should
No,
probably
yeah.
just be like, if you want to.
Yeah,
or
I
if you
think
need extra
so.
help.
If somebody needs extra help, let's just do it that way.
Yeah,
Because
like not required, but
don't
it's
have to have a class. So it's really not, we really don't need that class. And so I'm going to, on the website, what I'm going to do is just say, let's see, here we go. Let's see if I can make this. Honestly, my computer. So I'm going to change this to Wednesday. Can everybody see this? Instead of Zoom class, I'm just going to say tutoring at 10:30.
Okay.
All right.
Yeah.
And
Mhm.
so then the final is 8 to 10 on Thursday, and that's set by the school. So I didn't set that. And so I'll change this as soon as I get the chance. And so the other thing I want to call your attention to is last class, somebody asked about getting to the chapter tests. And so this was the instruction, and I was able to make that work, going to the ebook. And then, let's see if I can demonstrate it for you. My computer's acting funny. So we go, it may or may not, no, I didn't want to open this morning.
Yeah, me too. I try, many times. It's not open.
And I made it work the other day. Let's see. But that was literally how to do it. And then there were 3 lines, horizontal lines that let you do the content. I think it's my computer and I'm on the wrong, I should be on Chrome. But anyway, there's that, and there's also the reviews. Remember the review tests that we had before? I've opened them all up. So you can go ahead and look at those again. For practical purposes, the world's worst questions are not on the final. It's the things that we focused on, that we paid attention to, that we needed. And so the final has 25 questions. There's 2 hours. And so there should be enough time to do it. And so anyway, that's our plan. That's our game plan for Thursday morning. I'm going to stop recording right now.